Okay, so we have integration by parts today. When an integral is too difficult or impossible to integrate with standard formulas, we use something called integration by parts. And if we choose u and dv carefully, then we will make the integral easier to integrate. So here is the formula for integration by parts. It's the integral of u dv, and it will equal u times v minus the integral of v du. Whew. So looking at our integral, we want to make the correct choices for u and dv. That's where we will start first. So let's practice this on the first integral we are given. Here we're given the integral of 4x e to the 5x dx. Okay, so whenever we're given an integral in this form, x to any power of n and e to any, I'll just say e to the x dx. Whenever we're given an integral in this form, which looks almost identical to this, you will always let u equal x to the n, and you will always let dv equal e to the x. If you do it the other way, if you let u equal e to the x and dv equal x to the n, then you will end up in a never-ending cycle of integrals. So I'm giving you a hint here, right? So this is our tip. There we go. So if it's ever in that form, you let u equal x to the n and dv equal e to the x. And now I'll show you what to do with that. Okay. So we are going to let, like I said, u equal 4x and dv equal e to the 5x. Now here's how integration by parts works. So for u equal to 4x, we are going to take the derivative. For dv equal to 5x, we are going to take the integral. We are going to integrate. I guess I should say that. Integrate. We're going to find the antiderivative. Okay, so looking at u equal to 4x, when we take the derivative, it's going to be du equals 4 dx. And now looking at dv equal to e to the 5x, when we do the antiderivative of e to the 5x, remember there's a formula for this. Let me write it down real fast. The integral of e to the ax dx is 1 over e to the ax. So that's what we're going to use on this. So since that's e to the 5x, you're going to get v. So the antiderivative of dv is v. And the antiderivative of e to the 5x is 1 over 5 e to the 5x. There we go. Okay. All right. Now here we go. We've done the derivative. We've done the integral of u and dv. And now we're going to follow the formula above. So let me just do a quick rewrite. You have the integral of 4x e to the 5x dx. And now, using this formula above, we're going to start by doing u times v. So u times v. 4x times 1/5 e to the 5x. Minus, now we'll start here, the integral of v du. The integral of v du. Or if you want to sound cool, you say the integral of voodoo. So you'll have 1/5 e to the 5x times 4 dx. Should probably drop that down a bit. Let's see. Sneak in there. Boom. I'm just going to move that there. I lost a parentheses. It's okay. Okay. And now let's go ahead and clean up. We'll start here first. 4x times 1/5 e to the 5x. So I'm going to put that 4 and that 1/5 together. Everything here is connected by multiplication. So I can rewrite it and rearrange it using multiplication properties. So this is going to become 4/5 x e to the 5x minus, and the same thing is going to happen here. I'm going to clean this up, and I'm going to put that 1/5 with the 4, which is going to become 4/5, and I'm going to move that to the outside of the integral. You'll get 4/5 times the integral of what's left over, e to the 5x dx. And now all we have to do is break this down one more time by doing the antiderivative of e to the 5x. All right. So the leading term stays the same, 4/5 x e to the 5x minus 4/5 times the antiderivative of e to the 5x, which is again going to use this formula. And it's going to be 1/5 e to the 5x plus c. All right, almost done. Don't worry, I'll put it back in its place. We get 4/5 x e to the 5x minus 4/5 times 1/5 is 4/25 e to the 5x plus c. That's it. That is how you do integration by parts. And again, why do business majors need to know this? I have no idea. Maybe in the hopes of turning them into math majors. But again, just see it as fun. All right. Any questions on that? We good?
Good.
All right. All right, let's do it again. Okay. 2. Now we have a different form than the one above. This is the integral of x cubed times the natural log of dx. So again, you have to be careful choosing who's u and who's going to be dv. Well, for this problem, we're going to have to make u the natural log of x, and we're going to have to make dv x cubed. And the reason for this is because if we let dv equal the natural log of x, we have no idea what the antiderivative of the natural log of x is. We know that the derivative of the natural log of x is 1/x, and then we know that the integral of 1/x is the natural log of x, but we have no idea what the antiderivative of the natural log of x is. That would take a lot of finesse that we don't need to use in this class. So for this type of problem, let u be the natural log of x, and let dv be x cubed. And again, we will derive and we will integrate. So take the derivative of the natural log, and it's going to be 1 over x dx. Take the integral of x cubed, and you'll get v equals x to the 4th over 4. Okay, there it is. We set it up. We can now follow the formula. And I'll just start by following the formula. U times v, natural log of x, times x to the 4th over 4, minus the integral of v du. X to the 4th over 4 times 1 over x dx. There it is. We're all set up for integral by parts. Let's clean up. Let's make it look pretty. And on the first term, that is the natural log of x times x to the 4th over 4. What I'm going to do is move that fraction of 1/4 to the front. So you'll get 1/4 natural log x. Actually, I'm going to move 1/4 and the x to the 4th to the front. So I'm going to 1/4 x to the 4th natural log x. There we go. There's our rewrite. Minus, now over here, I again have a 1/4, a fraction of 1/4. So I'm going to take that, move it to the outside, and then what you're left with is, x to the 4th times 1 over x dx. So that's all I did there. Move that 1/4 out. And now clean up one more time, and we should be ready to find the antiderivative again. Now, x to the 4th times 1 over x. That reduces to x cubed dx. Okay, let's go. We're ready. Leading term stays the same. Minus the 1/4, put a bracket there to be neat. And now we get the antiderivative of x cubed, x to the 4th over 4th plus c. One final rewrite, 1/4 x to the 4th natural log x minus 1 over 16 x to the 4th plus c. Done and done. And there we go. Any questions on that one? See, isn't this a fun time?
Yes.
All right. All right. Last one ever. So sometimes we get an integral that will require us to use integration by parts multiple times. We will repeat integration by parts until we produce a simpler integral. Okay. So number 3 is just like number 1. It has that special form. This one looks like x to the n times e to the x dx. And if it has that special form, then we will let u equal x squared and dv equal e to the 2x. And that was the hint that I wrote above. So if it has that form, u will always equal x to the n, and dv will always be e to the x. Okay, so now we do the derivative du equals 2x dx. And then we do the integral. V is 1/2 e to the 2x. And then we follow the formula. U times v, x squared times 1/2 e to the 2x minus the integral of v du. One half e to the 2x times 2x dx. Okay. Perfect. And now clean up, make it look nice. On this first term, I'm just going to bring that 1/2 to the front. So you'll get 1/2 x squared e to the 2x minus, on this next one, your 1/2 and your 2 will cancel because 1/2 times 2 is 1. So those will cancel. So gone, gone. And what we're left with is the integral of e to the 2x times x dx. Where, if you want me to rewrite it as x squared e to the 2x minus the integral of x e to the 2x dx. There you go. I just rewrote it so the x was in front. And look at this again. We have the special form of x to the n e to the x. So we have to integrate by parts one more time. Which means u is going to be x and dv is going to be e to the 2x. And now du equals 1 dx, and v again is 1/2 e to the 2x. Now set up the formula one more time. This leading term stays the same. And now minus, now put a bracket here because we have to do the formula all over again. It's going to be u times v. So x times 1/2 e to the 2x minus the integral of v du, which is just going to be 1/2 e to the 2x times 1 dx. Close bracket. And of course, clean up, clean up, clean up. So this term stays the same. We distribute that negative to both terms. And for this term, I'm going to put that 1/2 in front. So you'll get 1/2 x e to the 2x plus, and then for this term, I'm going to move that 1/2 out of the integral. And of course, 1/2 times 1 is just 1/2. So I'm going to move that 1/2 out. And you're left with the integral of e to the 2x dx. All right, we're almost there because now we have ended up with an easy integral at the very end, and we're going to find the antiderivative of e to the 2x one more time. We've done it twice already. So everything here stays the same. 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/2 times the antiderivative of e to the 2x, which is again 1/2 e to the 2x plus c. And our final cleanup, 1/2 x squared e to the 2x minus 1/2 x e to the 2x plus 1/4 e to the 2x plus c. Done, done, done. And that is integration by parts, guys. We are done. Forever.